Okay, our next speaker will take us through the UCSDN activity group review, for which is the chairman of that activity group, and is currently principal program manager for Microsoft for Skype and Link partner engineering at Microsoft, and he's a proven technology leader with almost 30 years of experience in networking. He's held various positions throughout his career for Microsoft, Altigeo, NodeLogic Networks, Terabeam, Packet Engines, and Alcatel-Lucent, and Connexus. Pascal holds many patents and has co-authored many standards. So please welcome Pascal Menezes.
So, can you hear me okay? Okay, great. Thank you for being here. It's awesome. Welcome to Microsoft in Redmond in Seattle, beautiful sunny Seattle. This is how it's like 9 months of the year. So imagine I have to live here. And by the way, I came from Jamaica. No, just kidding. So anyways, I'm the chair of the UCSDN activity group, and I'm going to take you through what we've been working on. As you saw in the keynote today from Todd, did a great job of the kind of vision, what we're seeing around UCSDN. I'd also like to introduce co-chair Chris Lawyer, who's actually been the editor of our use case docs, done a phenomenal job. And tomorrow, Chris will talk a lot about that use case, the automating quality of service, quality of experience use case. And he'll take you to very minute details about that. So hopefully that'll be really awesome. So let me go on. I got an extra 15 minutes today, so I'll be much more longer-winded. So as Todd showed about, what are we trying to do here? Basically, the idea is, up to now, SDN, software-defined networking, has been in the data centers like Todd talked about, but mainly it's about, automating and reducing the TCO and, increasing efficiencies in the data center. But as we move this out, and it is moving out into the wide area networks, you'll see a lot of announcements coming from a lot of major vendors in the networking world, all about the wide area network, the enterprise, and so on. The idea that today applications have been thought of as, network service applications like virtualization apps, orchestration apps. But the idea of end user apps, as Todd talked about, is kind of new. And the idea that we can have UC that's very voice and video intensive, long-lived flows, and they could program the network is kind of very revolutionary if you want to think about it. And since we've been seeing 60, 70, 80% of the whole network's going to be voice and video, there's a great opportunity, whether you're on Netflix, and it's streaming, or whether it's real-time, interactive voice or video, the ability of programming the network is a pretty powerful concept. So I think this in essence is, is really the vision that we hold as a group. How can an end user app program the network? And to do that. And before SDN, software-defined networks, that was really hard to do because all these elements were distributed and there was not very many a central point to be able to send policies in a very dynamic way per session. Certainly network management systems did it on long-lived kind of provision by administrators, but not per session. So this is a very powerful idea. So I'm going to take you through the details of this and explain this some more. But I hope everybody got some great value in the keynote about what this means as an evolution. And certainly this is a decade-long evolution in software-defined networks. We're seeing a big retooling in internet networking right across, under the whole software-defined networking and network function virtualization paradigm. The idea, can we move the intelligence out that's currently distributed everywhere and bring it in a more centralized place where we can then work from it, whether it be from services or provisioning, or whether it be programming it from end user apps and so on. So again, it's all about complexity. The complexity of the data centers have proven this out. We had to automate, get efficiencies. We're seeing this all over the wide area networks. We're seeing this in every aspect of networking. And so we have ability of actually utilizing this technology, utilizing this paradigm change that's going to occur over the next decade as everything retools. And just like VoIP retooled into UC, standard IP telephony retooled into UC is a full kind of workload, whole new work processes utilizing all types of modalities. This is happening in networking too. So as you can see, the market dynamics are huge. They're, whether these numbers are accurate or not, plus or minus 15, 20, 25%. They're still very large numbers. And these large numbers mean that if you talk to any service provider, you talk to any cloud provider, they're all going in this direction. And today, all data centers are converting into being like a cloud infrastructure. So basically, as an essence, SDN is emerging in, and it'll be a decade retooling it, and so this represents some of the economics to that. But I wanted to take you through like some of the more details of what we've kind of been, these constructs that kind of helps the group kind of digest what we've been working for in the group, within the group, and kind of tie this all back into how do we finally get to a specification. We talk about standards, so how do we get to a spec that people can implement? I'll tie that in a few slides. But if you kind of bear with me, I want to walk you through the constructs of how we see this kind of working together. These are very simple kind of marketing constructs. By no means do they define the actual interface in any technical way, but they're meant from a marketing point of view. The idea is that as signaling happens, it talks some kind of central server, and then finds the other endpoint. Okay, then media starts flowing, whether it be to a PSTN gateway or a SIP trunk or to another user or whatever. The idea media starts flowing, and then basically we can program the network through this network controller, this SDN controller, and then that can program from the southbound interfaces down into all the different network elements. Someone mentioned, I think in the keynote, does it have to be all SDN? The answer is no. In fact, what you're seeing is, coming out now is, this network controller is the abstraction layer from the network, and these southbound interfaces that talks to these network elements are now starting to appear in all kinds of flavors, not just OpenFlow. So the idea, could you actually do this with CLI commands? Possibly. If the controller could actually model CLI commands in a way that it could talk to it from a command line interface, like a user would do, or a script, it can actually program the networks. So you're going to see a lot more of these kind of southbound interfaces start to appear, and this new kind of layer show up in the network, called this, this controller layer where all the intelligence is. Traditionally reserved by network management is morphing itself to a much more dynamic, fluid, agile kind of system, and have more automation and analytics in it. We talked about the last couple of presentations, I think, on the from Blue Jeans talked about analytics, needing the ideal analytics. Well, analytics sits in this layer in the network controller. This is the essence of where the network control will play a huge part. Centralized brain, if you want to think of it. Much like the SS7 kind of networks were. So basically, that's the first construct. As a session starts up, program the controller runs some kind of analytics to then do some kind of use case, whether it be programming quality of service, traffic engineering, programming security rules, whatever. This is the idea. And this works really well because voice and video has long-lived flows. It's not a fast transactions for milliseconds. It's absolutely minutes to more likely hours kind of transactions. The second construct is if I'm actually in a session and I have some problem happening in the network, right? Could we actually react to it by telling it, because only the endpoints really know the quality of that session, and it knows by how much packet loss, jitter, and delay it's getting. Could it tell that to some central intelligence, like a controller, and say, hey, I'm having a problem. Can you fix it? Can you do something? Can you reroute the session? Can you check if there's congestion going on? So whatever that analytics sits in that network controller, it can go ahead and try to reprogram that out. So for example, in the main kind of examples, could this kind of send it so it reroutes itself into a different kind of media relay, or whatever you guys call this, relay kind of points. And so another example will be exactly a programming quality of service, traffic engineering your route. Another example that's just starting to merge now. So these two kind of events are being described in our use case documents, more like in the first one for the quality of experience one, and this second one will be used in our use case for automating diagnostics. But the one that we've not really talked about that's starting to come in is the idea, if there's a problem on the network, and the network obviously knows it, can it go ahead and surface that up to the application so the application can do some pretty amazing things like increase and change its forward error correction algorithms. Can it use a 1+1 and copy, replicate the packets and space them 3 packets apart? Could it change the bit rate of the codecs and change the codec types? Could it change the media relay points or the relay points it's using to avoid congestion on a BGP peering link or a transit link and use some other relay point that is probably less congestion? So these are the ideas that become very powerful if the network can now communicate back up to the application and it completes this whole loop. And this is really what Todd was talking about, this idea of universal communication in the network kind of world, that we now have the idea that the SDN controller not only can talk to the network and the devices, as he showed in his slide around Wi-Fi as an example, but can it actually, the network, talk back up to the service? And so the service can do some pretty amazing things. And this is the idea of analytics. Now, analytics can sit not only in the network controller, but can sit up in the application layer. So it can get network knowledge about what's going on, whether it be Wi-Fi or whether it be networks in wired or wide area or MPLS networks, doesn't matter. The idea that the application can sense and get a pulse about what's going on and then adjust itself instead of doing all these kind of packet training technologies to kind of probe what the network's doing and all this kind of stuff that goes on today. So this idea of applications and network communicating to each other is really the kind of philosophy we've been kind of pioneering and kind of evangelizing, if you want to think about it. So you'll see today, in the next few sessions, actual product shipping in this kind of area. Now, the last one is kind of very new thinking, and that's where we want to get to, but you'll see the first two constructs, you'll see some product vendors showing this in real life working. So as Todd talked about, these are the scenarios, and I want to kind of go into it. The lowest hanging fruit we have is diagnostics. And this use case, I'll cover it in a second. We're actually working on this use case right now in the group. And this is actually about how can we, when a call goes bad or a voice call goes bad or something goes wrong, how can we know exactly what's going on instead of sending 10 highly paid engineers spending 14 hours to go figure out what's going on. So this needle in the haystack problem is very severe, very hard to solve. And it's difficult and it's expensive. And when you talk about adoption, moving to a full UC environment, it's tough because if you think about it, in the old world, we had VoIP handsets that were attached in Ethernet, plugged into a wall, that was spitting out only voice packets, were attached to a VLAN that was only voice, hardened by the administrator, traffic engineered to the data center, to the gateways and the MCUs. Very, very great science put in place for a decade. Then UC comes along and says, wait a minute, we're going to have soft clients that spit out voice, video, and data. And by the way, it's not going to be Ethernet, it's going to be on Wi-Fi so they can move, right? And now all of a sudden traffic engineering goes out the window because everybody's moving. And so the idea, and then you've got a wireless infrastructure that's half duplex in nature and shared in bandwidth for contention, and this causes even more problems. So now go find the problem where it is. Is it the Wi-Fi? Is it the device driver? Is it the software or the application layer? Is it the wired WAN infrastructure? Was it the service of the MCU or the gateway? Or was it the PSDN network? I mean, a lot of moving parts involved. Now, why I say this is this affects adoption. If we're going to have a large amount of customers move to this new paradigm of this converged of voice, video, and data, these applications, then it's important to give them the ability to manage all of this environment. So this lowers their TCO. So this, I think, is a very low-hanging fruit that we're going after. The other one that we know is also very low-hanging fruit, and you'll talk about how we solve this in the group, is we built a use case around this, is how do you automate quality of service? Because if users are now moving all over the place, and they're using Wi-Fi to get over, or they can go in LTE, how do you deliver this automated world where the application just signals its requirements and the network just plumbs all the right policies, like what we call access control lists, ACLs, but do a dynamic ACL? Because today, if you think about it, the network guys don't trust what applications mark. So if you mark your distort code points and you mark them with the voice value, they're not going to obey it because they don't trust some device, a BYOE device, running some application saying, just trust my markings. So now you need to have these access control lists put in all over the place. But what's the actual policy and what's the port number? But there is no well-known port number because we're running RTP and it's UDP-based with no well-known port. that the port number is derived from the SIP signaling, which is encrypted. So how do I figure all this out? So do I put this whole range of ports to be saying if it's coming from 10,000 to 10,000 and 99, allow that to be all EF? That's kind of crazy because that opens the denial of service attack. It's a huge attack surface for a denial of service. So the idea that we can automate this for a very micro flow, for that flow session, for that time period, and apply this QoS settings and this traffic engineering to it is a very powerful idea. And Chris will go in much detail in his session tomorrow about this, articulating this use case really well. We spent a lot of time, I'll cover about what we're doing in this use case to market it, but we've spent almost 9 months a year maturing this use case. So this is well known, and I'll talk about what we're doing to standardize this use case. And then finally, the orchestration, as Todd talked about, the idea that the Xbox in his home was telling him that he had to go manually go plumb all these, blah, 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 technical policies. And even though he's a technical guy, I mean, if that came up with me, I'd say I have no time either, and that's the reality of life. No one has time. And so systems should automate themselves and provisioning themselves. This is really the reality of this use case. So certainly we've not touched this use case yet, but the idea of think about firewalls, think about IDS, IPS systems, DDoS systems. If everything's encrypted, how does a DDoS system and an IPS system know that this is a valid flow versus an attack, right? So we go to the cloud, we go to hosted services. We're going to have IPS DDoS systems everywhere. How do we know when packets are leaving our network to our customer's network and coming back into our networks? How do we know what's valid packets or not? And how does RPS systems, DDoS systems know to trust these packets? So this idea of this communication to our IPS systems, DDoS systems, that these flows are valid, don't go and scrub them, don't try to throttle them or block them, is going to be very important as you move to a cloud service. So this is an example of orchestration. So let me go through where we are, because I know this session is about bringing this consortium about members to what we're being doing in the group. And basically, our charter was, when we were at the UCI forum, we came up with this charter, and this group came in through the UCI forum merger. We came into the idea of, well, this idea of UCSDN is very powerful, what I've been describing so far. So we presented the board, we presented this charter was to really define use cases. And I think someone previous to me said, it's great that we're starting with use case, because I think that's the start of everything, is get the use case right, figure out what's the pain point, and then figure out the technical details underneath. So that's what we did. We said we're going to define use cases. We're going to make sure that SDN can handle those kind of broad stroke use cases that we think are problematic. And then basically, we're going to revisit that, go back to the board and say, yeah, can SDN do these kind of things we want to do? And kind of the board gave us a final approval and said, yeah, okay, go for it. Let's go ahead and start marching down and delivering on this. And so we said, well, initially, let's define the spec also. But at that time, the Open Network Foundation, which is the guys who are really standardizing, OpenFlow and SDN kind of all up, decided to look at the idea of a northbound interface, the thing above the controller. How do you talk to the controller? This northbound interface group started up. And the idea that if we had a liaison with them, it'd be a very powerful thing because they could do the specification and we could give them the use cases. And so that's what we came up with. The idea that instead of us doing the specifications, let's give it to the ONF for them to come up with the specification from our use cases, and together we'll work as a consortium of two forums working together to really go and deliver this end user app model. And that's exactly what happened. I'll cover that in a lot more details in the next slide about this liaison agreement and what happened. So the ONF now has this MBI working group. In there, there's a subgroup, which I'm the vice chair of, I'm chairing it actually, that subgroup, is basically how do you make end user apps talk to the networks and define the actual interface spec, how to do that. And that spec is coming out of our use cases that we're defining in this group. So does that make sense? And then finally, we want to finally get to a certification program. Eventually, when the spec's out, we've got the use cases, people are building to this. Do we want to have an interop, making sure things all work together, right? So that's really where we're trying to go in the long term as a certification. So I hope this makes sense, and we'll take some Q&As right after this in a second. So where are we in the status of all of this? So we meet every Wednesday at 10 a.m. Pacific time for an hour. You're more than welcome. And in fact, I encourage you and your colleagues to join us on these calls and help us continue to mature this activity group. We defined our first use case, automating quality of service, in March, and that was only about marking the packets for the right tag values as the packets came in the network, so that the ingress of the network was automated to mark the flows as they were programming. The UC app was programming the network. The network would just automatically sense the right sessions and put the right ACLs in place at the right ports and so on, and then mark it. But what we've done since then is we took version 2, we made version 2 that extended marking into full traffic engineering, full admission control, and this delivered what we call now quality of experience kind of system. It's a true analytical system that not only just marks packets now, but actually can help dynamic and automate the whole traffic engineering across a Wi-Fi network, across even the carrier network if they wanted to do that. And it kind of defines that really well. Chris will go into that again tomorrow and really articulate that use case. And then finally, we are now, we're in this next use case, which is automating diagnostics. And we're 3 or 4 sessions into it, good first draft going at it. We'll probably be early next year sometime we'll have that done. And we'll deliver that to the ONF to go ahead and add on their interface that will define for the QoS, add on this diagnostic piece. You'll also see that we're ready to go for a press release for this version 2 of this automating quality of experience use case. The press release is ready to go. I think it's its final tweaks. We're about to launch it, and there'll be a full campaign around this, and I'll talk about in this next slide. So basically, let me back up to the liaison agreement. The Open Network Foundation, like I talked about, is standardizing SDN. We have this liaison with them. The ONF MBI group that's doing this end user app has taken our use case, and we've now defined, I'm putting the hat off the ONF MBI, we've actually defined the actual, what we call information models from this use case. It's called UML information modeling. And we've now put that into an actual spec. This spec is very close to finalizing. We now have a 45, and I think it's like 65-page interface spec. This is a huge advancement, that we now actually have a REST-based interface spec that defines that automating quality of experience use case, exactly how you program it, how you define it, and how it operates in a very technical software development point of view, that developers can utilize it and build to it. Additionally, thanks to our friends at the ONF and the members, we've developed an actual reference code also. And additionally, there's been work at the university in Europe to take this spec, the reference code, and build an actual first open standard interface from the end user app, programming the network, and this time programming an open daylight controller, SDN controller, and having an end user app being some kind of UC VTC system having the standard interface and showing the automating quality of experience kind of use case. So this is a very powerful amount of work that's being done in the last year, and I'm really happy for all the contributors that have done a tremendous work. And certainly, I'm just the spokesperson for the hard work that's been happening with many people in the group. From most of you guys have been participating, especially Chris, and other people like Manfred from HP, and people from ONF who've done, from Sienna, who's done phenomenal work in this, getting us to this spot. So I'm extremely happy with this work. I cannot tell you how much advancements we've made in this year, and I think by the end of the year we'll be in incredible shape for this. I think the guys from Maine can use some of this stuff to affect the relays and the analytics that were thought about, what's going on with the network, how do we adjust ourselves, all this idea can now be applied into these kind of over-the-top kind of virtualized concepts of kind of the main ideas of using relay points to steer yourself across. So that's it for the liaison between the two groups. Like I said, I'm the vice chair of the MBI group, and I'm the chair of this group. So it's great to have this this kind of continuation between the two groups. The conferences, we do have a plan. I'm working with our marketing guys to come up with our plan. And we will be looking to speak at the Enterprise Connect in March, at the Open Network Summit. We spoke also last year. We're trying to get there this year. That's the big SDN conference that will be in the Bay Area. And then at Interop. And we did speak at Enterprise Connect last year, so we were lucky to have a session on this too. So hopefully we'll get sessions on that. We're working on that. And then finally, we have this great SDN track here, and you'll see some great companies from Aruba, from Nectar, Maru, showing their great products. And then finally, on the marketing side, we will have the press release of the automated quality of experience come out very shortly. We're going to have a featured interview. We're at the SDN Central. It's the big site that people want to know about SDN. That's basically it. So you're going to see that come out very shortly by the end of the year. You'll also see some social media landing pages at our website that basically has the ability for people to sign up and log in to get more members to come in from all this marketing we're going to do. And then finally, we're planning out the rest of the marketing for all of for calendar year 15. What we're going to do to really kind of get this message out, especially given that we're going to have the interface done in the ONF, and we're going to have our use cases done probably 2 by early next year. It's a great time to really do a lot of marketing. So that's it for me. I know I'm being given the hook to get off. So if you want to I'll be around later on. You can always talk to me, and I can answer any questions. Okay, thank you.
Can we take a minute for questions, or?
Yes.
Thank you. Yes, Charles.
Okay, yeah, thanks. Great presentation, and I'm a big advocate for this explicit application to network communication. So this looks like a good step forward. There are a couple things that sort of concern me. One is when I look at applications talking to the controller, it seems like, and in the keynote, I think we saw all different kinds of applications will need to be talking to the controller. So it makes me think that the way that the applications talk to the controller needs to be application, say, agnostic. So in the examples I saw, I love SIP too. I gave a talk on it earlier, but I see things like a SIP URI or a SIP call ID. That makes me think that maybe we need to think a bit more about how we make this general to other applications, not just the UC ones that most of us in this room really care about, but other applications too. So just curious your thoughts there.
Yeah, so in the end user app group, subgroup under the MBI group and the ONF, we're chartered for all kinds of apps. But again, we have to start with something. And we said, let's start with the real-time media apps, because they're the ones that are really sensitive to the network. So that's where we started. And so hopefully, by the end of the year, we'll have that spec done. It'll actually be called the real-time media northbound interface spec. But right after that spec's done, as we continue with the use cases in this forum to mature like the diagnostics and orchestration, we will probably take on and look at in other apps like we think about storage. How do we do backups and how much bandwidth they need, and like how do they program the network? It'll be different than how real-time apps would program the network. So we are looking at that all up. That helps.
Yeah, and maybe one other question. In my experience, the problems I see with like congestion loss, in terms of quality of service, is typically pretty close to the endpoint, my mobile device. So I'm thinking that we need to have some way to reach the mobile device to impact the network around it. So one of my concerns is if we're having the application server, which is perhaps in the cloud, and I'm on my mobile device in a coffee shop, and I'm having problems in the coffee shop, it seems like I need to enable my mobile device to talk to the controller or to somehow communicate some information, as opposed to this centralized application server talking to the controller. I'm wondering, are you thinking about possibility of opening this up to things from the other end, not the centralized, but more from the endpoint point of view?
I can tell you we've been doing a lot of thought of that inside our own group under Skype and Link. That's exactly right. And I do see this intelligence, this analytical intelligence, not so centralized like in a data center only, but more distributed out towards the end of the cloud, where there's domains of where it's responsible for. So the idea of programming a device Todd talked about is something we're very interested in. How do we program a device to behave a certain way when a voice session starts up on Wi-Fi or LTE? And then how do we program that Wi-Fi environment in an airport to support it, to let it know that a voice session is starting up versus just the cloud? Is that what you're talking about? Yeah. So we are looking at all of that, but again, we're still early days in the standardization where inside of Skype and Link, we're further out thinking about this and much further along the path of getting that than we are inside the standardization area. That helps.
I invite you to continue during the coffee break. So
okay, thank you.
Thank you very much again.
Okay.